Ladies and gentlemen, once again, we are here, Fraser Nation in the building. Today we're going to go over 4.4. We're going to prove triangles congruent by SAS and HL. As we learned in 4.3, we know that the S in SSS means side. So you probably can figure out by now that A means angle. So we have here side, angle, side. And right here, the HL, for those who really love geometry, is going to mean hypotenuse leg. So we're still under the same objective. Students will be able to prove triangles congruent by various methods. Here's two methods right here. This is the second one we've learned. This is the third one. And the first one that we know is SSS. We have two more after that. So, just stay tuned. Remember, hypotenuse is the side across from the right angle of a triangle. So for any triangle I have, let's get a triangle right here. Here's a right triangle, okay? And right here, since that's across, this is the hypotenuse, okay? That's the side across from a right triangle. A leg is a non-hypotenuse side of a right triangle. And there's always two legs, like there's two legs on a human. There's two legs in every right triangle. So right here, let's get a right triangle popping. That's an ugly right triangle, but whatever. This would be your hypotenuse, so this would be your leg. And over here, that would be your leg too, okay? And the word included, okay, means in between, okay? So if I have two sides, right, then the included angle would be the angle in between, okay? So if I have side A, B, and I have side B, C, then the angle in the middle, this is the included angle, okay? I just kind of wanted to give my visual people something to look forward to, okay? Let's go ahead and switch cards. Postulate 20 says the side angle side congruence postulate. If two sides and their included angle, so the angle in between of one triangle, so let's pick triangle 1, are congruent to two sides and their included angle of a second triangle, then the two triangles are congruent. So look at these two triangles, okay? This picture actually says, so if, okay, side XY, so if side XY is congruent to side AB, okay? So here's one side. Angle Y is congruent to angle B, okay? And side YZ is congruent to side BC, okay? So I have these two sides, so XY, BA are the same, YZ, BC are the same, and then the angle in between, angle Y, and angle B are the same, so they both have one dash. Then I can say triangle XYZ is congruent to triangle ABC. Okay, so X matches up with A, Y it matches up with B, Z matches up with C. Okay? So in your homework, you're going to have to prove two sides in that angle are congruent for two of the triangles to be the same size, okay? So remember, when we talk about these two triangles, we mean same shape, okay? And we mean same size, okay? Those both have to happen for triangles to be congruent, okay? Next card. Theorem 4.5 is hypotenuse leg congruence theorem. So if the hypotenuse in one of the legs are congruent to the hypotenuse in one of the legs of another triangle, then the two triangles are congruent, okay? So look at these two triangles. So they're right triangles because these little boxes mean 90, obviously. And if one of my legs, so here's a leg, and here's a leg. So if, well, let's go with the hypotenuse first. BC and EF, okay? So if side BC is congruent to side EF, okay? So hypotenuse to hypotenuse, okay? Let's say these are the hypotenuse, okay? And BA, or AB, okay, is congruent to ED, okay? So AB, ED, and that's one of the legs. I only need one of the legs, one pair of legs. So here's a pair of hypotenuse, here's a pair of legs. Then I know that triangle ABC is congruent to triangle DEF. Okay? So same size and same shape. Okay? So we have our ammunition. Let's go ahead and look at some examples. First example, use the diagram to name the included angle. So the angle, let's say in between. Okay. So the angle in between the given pair of sides. So let's work with red. And let's see. So side AB and side BC. Okay. So I want the angle in between. Okay. So this whole angle is the one in between. And remember, an angle needs 3 points. So I want the angle between side AB and BC. That's going to be angle ABC. Okay, remember, unless you have only 1 point on that angle, you have to use 3 points. So here's 1 point, 2 point, 3 point. Let's go ahead and erase that. Well, actually, no, let's keep that. Let's keep that. Okay. If I have side CD and DB, then I'm looking at this angle in between. Okay. So here's the side and here's the side. So I must want angle BDC. Okay. And problems in the homework are going to look like that. So just make sure you go ahead and give me the angle that's in between. Let's see. Decide whether there's enough information to prove the triangle's congruent by SAS or HL. It's a guarantee that we're going to use HL because we're dealing with right triangles. Okay. So if we're dealing with right triangles, it's a good bet that we're using hypotenuse because the hypotenuse only exists in a right triangle. Okay, so let's talk about triangle 1 and triangle 2. So first and foremost, if this is a right angle, this has to be a right angle. Okay, a straight line is 180 degrees. If this 90, this got to be 90. Okay, so that means that this must be a hypotenuse and this must be a hypotenuse. So first and foremost, we can say that BA is congruent to AD. Okay. And how do we know that? Because in the picture, they both have 2 dashes. 2. Look at this. Now, triangle 1, AC is one of the sides, and triangle 2, AC is one of the sides. Well, according to the reflexive property, we know that AC, side AC, has to be congruent to itself, AC. So we're going to say the reflexive property. Okay. And let's say this is given, okay, because the picture gives it to us. So if we know the hypotenuse in one of the legs, then we can say triangle BAC. Okay, we got to match the angles up. BAC has to be congruent to DAC. Triangle DAC. Okay, so that means same shape, same size. All right. So decide whether there's enough information. Yes, there is. Okay. Next. So here's A, B, C, and D. Okay. So in the diagram, A, B, C, D is a rectangle, which means all corners are right angles. So B is a right angle, BCD is a right angle, CDA is a right angle, and DAB is a right angle. Oh, damn. Anyway, what can we conclude about triangle ABC? So here's triangle 1 and CDA, triangle 2. Okay. Well, first and foremost, we know that AC of this triangle, okay, AC is congruent to AC of this triangle, okay? We know that AC is congruent to AC, okay, because of the reflexive property, okay? And why did I draw these arrows? Well, because AC is a hypotenuse, okay? So let's go ahead and say this is the hypotenuse, okay? So if we're talking about hypotenuse, we must be talking about hypotenuse leg, okay? So if we're talking about hypotenuse leg, we can figure that out. And this is something you really don't know yet, but I'll tell you. In all rectangles, opposite sides are congruent, okay? That's something you really don't know. So in a rectangle, opposite sides are congruent, okay? So I know that BC and AD are the same, okay? So let's say AD is congruent to BC, okay, because op sides are congruent, okay? So here we go. Hypotenuse, and since this is not the hypotenuse but it's a right triangle, then we know that one pair of legs are congruent. So we know that triangle ADC, okay, match your angles up. ADC is congruent to CBA. Wow. Okay. And I don't know why I did that. Because really we were talking about here, these two triangles. So if that confuses you, go ahead and say CDA, same triangle, is congruent to triangle ABC, okay? I would have accepted either one. It's all good. I figure maybe we need one more example. What y'all think? Or y'all think y'all good? Well, if you have any questions, let me know. Fraser Nation, signing out once again. And yeah. See ya!